Hello again, Tom from Every Step Calculus, everystepphysics.com. This is a Taylor series problem. You can see it came from Yahoo Answers. I like that because kids, bring their problems into Yahoo to try to get some information about the problems because their pathetic calculus teacher doesn't teach right, which is the usual case. Doesn't teach the systems of passing a test and actually the mechanics of doing problems. They teach theory and try to have you understand all this stuff. And we don't want that to happen. We don't want to learn anything about calculus because it's such a useless math concept. And that's after 30 years of studying this stuff every day. So, but anyways, let's do this one here. He says, I'm so confused with this stuff. I know a simple example is this. And he gives you this calculate the Taylor series centered at the given point alpha. And alpha is close to what you choose on the x value and y value for the derivative. And so the function is e to the x. They use e to the x, log of x, sine of x, cosine of x. Simple functions because they have repeating derivatives, okay? And that's what is required in Taylor. So let's do it, e to the x. Index 8 to get to my menu. Press enter. I'm going to go up with the cursor because I'm going to go to the bottom of the alphabet and get to the T section of my menu and get to Taylor. There's Taylor and Maclaurin. We press enter. And of course we have these options. You can find the coefficients of the Taylor series, you can find the Taylor series, you can find the Maclaurin series, and you do the ratio test. So right now we just wanted this problem here, wants you to find the Taylor series. So we're going to choose number 2. And right away I give you the formula. That's necessary. Now you already got 2 points on your test when you mark this down, okay? And then if you want to be a genius, you can mark down the Taylor series summation notation, which is this. The sum is, which is basically what this answer has done. And that's the formula, f to the n over a, and then over n factorial. N is how many times you're doing something. For instance, if you're doing the derivative number 1, that's number 1. If you're doing a derivative, the 5th derivative, number 5, then you're doing 5 here for n, okay? And a, they gave you the value for alpha. So let's enter the function. We have to press alpha first in my programs. I pressed alpha here. And then to get to the a, you have to press this yellow button here and go to the x, which brings up the e to the, and then we press x and put the parentheses in there. So we got e to the x. And then I ask you centered at a equals 5. So we go to alpha 5. Now this kid says, the simple Taylor series, please help. Taylor series is not simple. A lot of things to memorize, a lot of things that doesn't make sense, and we don't care about learning it. I've studied this for a month to get even close to this, and I did it several years ago, but then I always get around to cleaning these things up as I got more knowledge about programming and more knowledge about calculus. Not simple. And so anyways, I always give you a chance to change this in case you made a mistake, but it's good, so I'm going to press number 1 here. And then I tell you what I'm doing. I'm going to find the succeeding derivatives of e to the x. Well, that's easy because all the derivatives are the same. Here's the 5th derivative, e to the x, so equals e to the x. I'm going to compute the derivatives with a equals x, okay? F of x is the function. F of a is what we're dealing with Taylor. And so we're going to enter 5 for a, which is the function at 5. So we do that, and up comes e to the x, e to the 5, all the way down the line here. Now if you kept going, you'd have 7, 8, 9, 10, 150,000 derivatives here. And we're going to sub that into the formula. And of course, divided by 0 factorial, 1 factorial, 2, 3, 4 factorial, etc. These are all the series computations here. Now we're going to calculate the factorials times the derivatives. Now I don't know what your professor might have you do, but you have to keep abreast of that. You know, right now I'm taking 0 factorials times, which is 1. E to the 5 divided by 1 is e to the 5. And of course 1 factorial is 1. It's e to the 5, etc., etc. here. Here's 2 factorials, 3 factorials. 1 times 2 times 3 is 6. 1 times 2 times 3 times 4 is 24, etc. And 5 factorial is 120. Now maybe your professor wants you to put down 2 factorial or 3 factorial or 4 factorial or 5. You have to be hip to that so you can, you know, I like to compute the whole thing. And here's the answer. E to the x is equal to E5 plus e to the 5 times x minus 5, etc., etc. So here's what you put on your paper, and you'd look like a genius, okay? So go to my site, check out my programs, and, you know, buy my programs if you want to pass calculus. It certainly is. Or if you can study it for hours and never really know what you're talking about. Believe me, I know what I'm talking about with calculus. Extremely difficult. Calculus is like doing Sudoku puzzles or crossword puzzles, and then when you get done, you've done nothing. You've done nothing. For instance, even here, look at e to the 5 times x minus 5 to the 5th power 1. If you graph e to the 5, e to the x, it turns out to be a graph like this. Under the x to the 0, 0 here, the origin of the graph, and then goes up like this forever, okay? So now if you go 1, 2, 3, 4, 5 and go up and touch this graph, you know, whatever that turns out to be for the y value, that's supposed to be the slope of that line, and that's what derivatives are, the slope of a line, okay? So you can experiment yourself with this stuff, and I can't get it to work out. This is the correct answer, but if you put 5 here, 5 minus 5 is 0, so this is 0, and the whole thing is 0. So where's the slope of the line in this, you know? But I mean, this is all just a lot of baloney as far as I'm concerned, you know, completely useless in your life, never use it. But anyways, it's nice to get the answer right for a test and get your A and get out of there and get onto something important in your life. So have a good one. Think about my physics programs too, which are great. Everything step by step. And go to my site, buy my programs, and if you feel like it, subscribe too for more videos on things. Have a good one.